Hi and welcome to this fourth video about the best methods to oxidize primary alcohols to aldehydes. This video is about oxidations with the derivatives of 2-iodobenzoic acid. These reagents are expensive if compared to the other oxidants of this playlist, but can offer a valuable alternative for small laboratory preparations or the oxidation of expensive alcohols. 2-iodobenzoic acid itself is no oxidant, but it can be converted into 2-iodoxybenzoic acid, the so-called IBX, by treatment with bromate or oxone. IBX has a better solubility than simple iodoxybenzene, but its solubility in most solvents is still low. As I'll show you in a minute, IBX readily oxidizes alcohols to aldehydes or ketones. A reagent with improved solubility is the desmartin periodinane, which results upon treatment of IBX with acetic anhydride. This is a kind of mixed anhydride of the iodoxyarene and acetic acid, but does not cause acetylation of alcohols, but, like IBX, their oxidation to aldehydes or ketones. Here are some references about these reagents, including iodoxybenzene. The mechanism of alcohol oxidations by IBX is an initial condensation followed by fragmentation into the aldehyde and 2-iodosobenzoic acid. No additional bases or acids are required, just an inert solvent such as dichloromethane or ethyl acetate. Oxidations with desmartin periodinane proceed similarly, because in both oxidants iodine is at the same oxidation stage. In most reported examples, one equivalent of IBX or desmartin periodinane was used. Few examples have been reported though, where alcohols were oxidized with only catalytic amounts of these oxidants, combined with stoichiometric quantities of another oxidant. I'll show you an example in a minute. Not all hypervalent iodine derivatives react with alcohols in the same way. The less expensive sodium periodate does, for instance, not oxidize simple alcohols, unless combined with additional reagents or catalysts. Only 1,2-diols are cleanly cleaved by periodate into 2-carbonyl compounds. Similarly, iodobenzene diacetate only oxidizes alcohols when combined with bromide or some other catalyst. IBX or desmartin periodinane, on the other hand, do not usually cleave 1,2-diols, as shown here. Only sterically crowded 1,2-diols may also be cleaved into ketones by IBX. The main advantages of oxidized iodobenzoic acid derivatives are the high selectivity of these reagents and the simplicity of their use, because only one reagent is needed. Moreover, the reaction conditions are mild, yields are generally high, and few byproducts are normally formed. Main disadvantages are the high price and their tendency to explode when heated strongly. Their selectivity will also drop if forcing conditions are required. Unfortunately, only few examples have been reported of the use of catalytic amounts of these oxidants. This here is an example from organic synthesis. The main problem was that oxone had to be dosed precisely because an excess of oxone caused over-oxidation to the carboxylic acid. Because of the variable water content of oxone, such precise dosing can be difficult to achieve. This here is a typical oxidation of an alcohol with the desmartin periodinane. Just one equivalent of the oxidant was enough for a complete conversion in only 1 hour at room temperature. Electrophilic enones, as the one shown here, did not undergo epoxidation or Baeyer-Villiger oxidation. In the case of diols, it is often the sterically more accessible primary alcohol which reacts first. In this example, despite the excess of IBX, no ketone was formed. Also an amide and an acetal remained unchanged. During the oxidation of alcohols, also amines are occasionally converted into imines. In this example, though, no such side reaction occurred. Also a benzylic tertiary amine and a pyridine were compatible with the desmartin periodinane. Also in this case could an alcohol be cleanly oxidized in the presence of a secondary amine. Bicarbonate was added, but this might not have been necessary, as shown in the previous example. Anilines can be readily oxidized to a huge number of weird, often intensely colored products. In this example, however, a primary alcohol containing an aromatic secondary amine was oxidized with the desmartine periodinane in high yield. Admittedly, nitroanilenes are more difficult to oxidize, what may have contributed to this result. Carboxylic acids are also compatible with IBX or the desmartine reagent. Here, a hydroxypropyl acrylic acid could be oxidized in high yield to the corresponding aldehyde at room temperature. Even thioethers can remain unchanged upon oxidation with IBX, as shown here. DMSO was chosen as a solvent, but most reactions proceed faster in DMSO than in other solvents, what can cause a decrease of selectivity. Nevertheless, no sulfoxides or sulfones were formed during this synthesis. Also, primary nitroalkanes can remain unchanged during alcohol oxidations with desmartine periodinane. Despite the excess of oxidant, no dehydration of the nitro group or oxidation of the indole substructure occurred. Nitroalkyl aldehydes, such as the product formed here, are particularly sensitive and will tend to undergo oligomerization by aldol condensation. This may have been one reason for the fair yield obtained here. In this example, the starting alcohol contained a primary nitro group, an acetamide, and a diisopropyl ether substructure. Despite the excess of IBX and the elevated reaction temperature, only the alcohol was oxidized and no oligomerization of the product occurred. Here a diol containing a sulfoxide had to be oxidized twice. This could be accomplished successfully with a slight excess of desmartine periodinane at 10 degrees Celsius without oxidation at sulfur to a sulfone. Let's have a look at potential side reactions. With an excess of these hypervalent iodine reagents under forcing conditions, the initially formed aldehydes can be oxidized further to carboxylic acid derivatives. Here a hydroxysuccinimidyl ester was obtained upon reaction of a primary alcohol with an excess of IBX in refluxing ethyl acetate. With a large excess of IBX, enolizable ketones may also be dehydrogenated or alpha-hydroxylated, as in this example. Reactivity-enhancing solvents such as DMSO, sulfolane, or acetonitrile may promote such reactions. 2-methoxyphenols can be cleaved by IBX into catechols or, if an excess of oxidant is used, into orthokenones. Methoxybenzenes without an ortho-hydroxy group, however, are usually not cleaved by these reagents. Occasionally, alkenes may be hydroxylated or even cleaved by oxidized 2-iodobenzoic acid, as in this example. This is only rarely seen, however. And as shown on the previous slides, alkenes are usually compatible with IBX-mediated alcohol oxidations. Further functional groups that may be oxidized or otherwise transformed by hypervalent iodine derivatives are shown here. These include phenols, amines, alkyl arenes, ketones, silyl ethers, and epoxides. Most of these reactions proceed more slowly, however, than the oxidation of primary alcohols. Here are further, mostly recent references, which you can also find in the description of this video. The next and last video of this playlist is about alcohol oxidations with chlorine, hypochlorite, nitric acid, and some further reagents. These are less selective than the reagents presented in the first 4 videos, but can be valuable alternatives in special situations. See you!